Hello, everyone, and welcome to Osquery Office Hours. It is January. It is cold here in New England, and there is snow all over an awful lot of North America. So, for those of you that are in the eastern parts of North America, I hope shoveling has been good. And for those of you elsewhere, you're probably happy about it. So it goes.
In this room, it looks like it's just you in the eastern part of North America, Steph.
I think so too, but I don't know if anyone watches or reads the notes later, so I pretend like I don't know the answer to that question. Anyhow, announcements, highlights since the last meeting? Okay. Any questions, issues, PRs, people we want to discuss? Sort of just meant as a bit of an open time. Okay.
I put my stuff on the agenda, but now I am attempting to buy my concert tickets.
Okay. So apparently one open issue here is that Zach is trying to buy concert tickets, and probably Ticketmaster or whoever is terrible. Do you know I used to work with someone who was like an SRE at Ticketmaster? And my memory of his stories is like they ran on like big, giant, weird old Vax hardware.
Oh yeah, I'm sure.
You know, just some incredibly big old chunk of code that hadn't been touched in a million years. Just big, big, big iron. So that's
yeah. Okay. It's the normal thing. You get the tickets in your cart, try to check out, tells you they're not available anymore. So I'm just gonna be like clicking in the background here, but so yeah, I wanted to bring up the toolchain build CI related stuff. First, there's the PR in the toolchain repo, which builds the toolchain on CI there. In my eyes, the advantage of this was intended to be that we don't have to rely on some Osquery developers' machine being trusted. We rely on trusting the GitHub Actions, and potentially it also makes it easier for us to track what configuration was used to build the toolchain, and etc. That PR I think is ready to merge. The one part that I haven't been able to test because it's trickier to test is the uploading to a release, if that works.
Doesn't that part just happen for free if it's in a release build?
No, it doesn't. It doesn't happen for free because I mean, it should work. It seems like it should work, but it doesn't happen. It doesn't happen for free.
Well, I mean, I think there's like an action for it, but I don't remember it being a confusing action or anything.
No, it's not confusing. It's just that like if you fuck up the paths or whatever, then you end up having to do another PR and then cutting another release, and it's just like very cumbersome feedback cycle. I think it's right though. I think it's right. The other part is right. The actions run on both ARM and x86 now. They upload the artifacts to the like actions upload artifacts, and then they'll upload those same things to the release.
Okay, I will try to review your PR.
Yeah, and then my intention
it looks pretty straightforward. So
yeah, my intention is once we've done that, I'd like to try updating the Osquery CI to use that new tagged release. I imagine it's like 1.1.1. So essentially, it should be the same toolchain but built on CI. Make sure that those builds that get generated on the like main Osquery CI work fine. And then once that happens, then start trying to update the components of the toolchain, particularly the Clang, I think, and libc.
This makes sense to me. Did we settle the question on, sorry, I'm typing as we go as well. Did we settle the question on whether to drop Docker?
Okay, so that's the other part. So this has always been without Docker. This
Right.
This toolchain, building the toolchain portion. To my understanding, in theory, I guess you could build it in Docker, but oh yeah, and actually there is some support for that. But nevertheless, I think now you're referring to my PR in the Osquery main repo, which updates the CI to now it's actually doing multiple things. One, it's updating the CI to use GitHub hosted ARM runners to do the ARM builds, and then it also gets rid of the Docker container used there. And I know there was like various discussion around that, questions on like, is there some sort of isolation that we care about that would be missing if we get rid of that? And there were questions about like, will the build take longer if we do it that way? And what I found is it does not take longer. So I think that the remaining question is sort of just like, are we okay? Do we need that level of isolation? Or was it giving us something important there? Or are we okay with proceeding without that? And additionally, do we see any like issues with the way that the moving to the ARM runners?
I haven't read this PR. I don't anticipate issues moving the ARM builds. The only reason they were on self-hosted runners is that GitHub didn't have ARM runners at the time. And I think I looked at moving it and just never completed it. So there's absolutely no reason not to do that one.
Yeah, so in the end, if this PR could be split into like add the ARM portion and then don't do the removing Docker portion. Again, I think I mentioned that in Slack, but the removing Docker was mostly for like simplifying the thinking about this whole process for me. I could also just build new Docker containers and push them if we want to go down that path.
I don't know. I honestly don't know. I feel like the original push to Docker was, I think, from Trail of Bits, and thus I assume from Trail of Bits customers. Alessandro or Stefano would probably know. It always seemed like a nice idea, right? It was meant to be like a step towards hermetic builds or repeatable builds. But like we never really got a good mechanism, the equivalent on Mac OS or Windows, right? For those, we're always kind of just using the CI machines.
But as Stefano said in the Slack, though, like Mac and Windows provide their own sort of like tool chains that do provide more of that kind of stability.
Yeah, it was more about the fact that with Docker you can you can freeze the user environment, and especially the libc that is being used to run Osquery and the tests. And this means that, again, the binary build we know that and the toolchain, we know that it is compatible basically with that environment. While it might happen that with newer version of Linux, we suddenly have like if the CI version of Linux we use is updated from the version we are using now, and the libc drops support for the old symbols of libc we are linking against, then the binaries are broken and we are forced to update the toolchain, or at least, yeah, we have to build a new toolchain that uses a new libc. So again, it was a balancing act, with a balancing between not having to update as often the toolchain if we don't have the bandwidth, while accepting to lose possibly support of newer Linux versions, since kind of normally we are targeted to more older ones. But yeah.
I guess I actually, looking at what the reality of the situation was, I actually have probably the opposite concern, which is that like we were using a Ubuntu 20 image to build and run those tests. So, which is, already out of support. And so in fact, like I think I would prefer to see us building on Ubuntu 22 or 24, or not necessarily building, because I think, as you say, Stefano, it doesn't matter as much for the building. It's for the running the tests. I'd rather know if it's breaking on Ubuntu, 22 or 24, the standard versions that like GitHub is shipping for their actions runners, because those I think are probably more representative of things that people are running in production these days than our old image, assuming that we don't keep it updated. But we did. The reality was we didn't. So
is there I can't remember. Sorry, I maintain too many software projects these days. Is there a way we can run tests on a larger variety of things? And like, what level of testing do we need to run across all the different OSs, right? Full integration tests, or simply can you exec it and like do something simple?
So one of the things that I was going to raise is along that lines. One of the core benefits of using containers, I'll use the generic term instead of Docker, is that you can run in parallel a series of tests on a wide variety of distros without having to have multiple virtual machines running. You can on one single runner have 4 or 6 or 8 distros. In our environment, we actually are doing this today with Ubuntu 22, 24, Fedora 43, Fedora 42, and we're looking at adding additional ones, and it allows us to, at a glance, see what things succeeded and what things failed very quickly in the different environments. I'm actually surprised to hear potentially moving away from containers instead of moving more towards them. They tend to, because the industry seems to be moving towards containers.
Some of that may also, everything inside GitHub Actions is in a container, and then we would run our own container. That we're like managing our own container.
Sub-containers within it, yeah.
I don't remember if it's a sub-container or just our own container image. Zach probably knows because he's in the thick of it right now.
Yeah, I mean,
everything
we
we're
have
doing
a container. We have a container image that we run. If we wanted to do some sort of like matrix of testing across different distros, I think we probably would use containers for that. But that's not what we were doing with the containers before. So it really, in my eyes, it was an extra layer of like abstraction, an extra place that needed to be updated without clear benefit, that was making it harder to understand the whole build process.
Okay. So I think.
So I do agree, like it might be useful to do more of that kind of testing, but this I would say is orthogonal to that. Because also the way that we were using the container was the GitHub Action supports, you can say like run this entire job in just this one container.
Yeah.
And we were doing that because of the API stability issues, I guess, that Stefano was describing. But then that didn't give us actually any advantage for testing other things. And in my argument is, in fact, it actually meant that we were still testing that things ran on Ubuntu 20, which is a lot less useful, I think, than testing on newer versions that are more likely to actually be in use these days. Now, we could have updated, the other option is we can just update that image. Like that's not a problem. I don't think it's just another step and another thing to be thinking about.
So I think we should put the test thing aside because I think there's actually an interesting question of how can we test across more OSs without maintaining containers across the board, right? And then we should be leveraging GitHubs. And then there's the question, what are we testing? And I think the question for us right now is really like, do we want to build in a container that we're maintaining or just build in the CI runners? And
Yes.
And
or build and run like the single set of tests. Like, should there be a way that we can run more of a matrix of tests? Seems like a great idea. Could be done, but I think
feels orthogonal.
Orthogonal, yeah.
So I think the argument for building within a container is if a developer on their local system needs to be able to build Osquery in the same way that we do, then then having a container that they can pull down and build the code within is the benefit. Now the question is, how often is that done, right?
I'm not sure because I think a developer building I build on macOS, which is different.
Yeah.
But I think a developer building on Linux could certainly just use the tool chain.
Generally, you pull down the tool chain,
but it's a different environment then. And what issues do they run into? So it's the whole,
none that anyone's raised.
Yeah, it's the whole thing of, is a reproducible environment, is having an identical environment across all developers beneficial for building the Osquery toolchain?
I think the better question alluded to earlier is around, do we want to do something to ensure that we're effectively locking our libc version to something older than oldest thing supported?
And to be clear, Stefano, please correct me if I'm wrong. To be clear, we are already locking the libc version that we build with. It's about the libc version that we that we run the tests with. So it's actually like it's a forwards compatibility thing. The toolchain already locks the libc version.
And
so then the question is that Stefano is bringing up is, do the tests run successfully on a newer Linux machine that potentially has a newer libc that has dropped support for some of the really old libc symbols?
Isn't the libc built into the Osquery binary? How does the
no,
statically libc contains the kernel hooks, so you can't statically link libc because then you're bound to a given kernel. So the kernel ABI is unstable, and thus libc is one of the only things you have to dynamically link.
Oh, so it's one of the few things that's dynamically linked. Okay.
Yeah, so everything else is static pretty much.
Okay.
But not the kernel interfaces.
I mean, I'll tell you, our kernel developers really want everything to be dynamically linked, but I know that's hard.
It also has a specific connection to PAM, like the libc compiled on the system, present on the system, is connected to a specific version of libpam. So if you have tables or anything that needs to communicate with that, when you are statically linking the libc, you're also freezing like the version of PAM basically you have on that system. And so there are also incompatibilities there between if you move that binary to an older version or a newer version, etc.
Okay.
But I think for the most part, actually, it's our belief that most Osquery users want most of the dependencies statically linked so that you don't have to install other dependencies in order to install Osquery. Because if you're on Linux, you've got libc. And then if Osquery includes all the rest of the library static link, then you're good to go.
Yeah, to build, you need CMake, the toolchain, and Make or Ninja, like the underlying build system, binary, and no, that's it. Yeah.
Okay, so to repeat what I heard, right, is that libc our tool chain already effectively locks the libc version. So the trade-off in removing the containerized build and test flow is that we are losing our current good or bad ability to test in a constrained ancient libc. And I feel like what that then does is actually bring up the orthogonal conversation of what would we want to test anyhow, right? So what we do for launcher, which is not the same as Osquery, right, is we build launcher in whatever, some reasonable thing that GitHub does for us. I can't remember what version. And then we take the resultant binary and we just try and exec it on a bunch of different operating systems and versions. And we assume that if it execs, it's probably good enough, and we don't really test the table validity across every ancient version because they all support slightly different things. So if we thought that that was a good enough test, that might be relatively easy for us to build inside a matrix style GitHub action, right? Of like, launch this container of an old Ubuntu, and does Osquery version produce data, or like select star from Osquery info.
Yeah.
We
I think-
we refer to that kind of testing as smoke testing. Is that kind of what you're thinking of? Is put together a small list of smoke tests, and the main one being, does it exec at all?
It depends what you're testing for. I mean, smoke tests are a word for it, sure.
Yeah.
But then I think that then the other thing that Philip brings up is, well, right now, perhaps it's easier to pull down that Osquery builder container and have a tool chain just ready to go versus having to install the tool chain into your own Linux container or VM or system. And so potentially we lose that. But that's also, we don't document that as the way to build Osquery currently, and I'm not aware that anyone does that. The way that we document building Osquery is install the toolchain on your generic Linux system.
It sticks it into a path, right? It's not like it pollutes your user lib.
Yes, that's right. It sticks into it.
You know, another question, and if we decided we wanted to keep the Docker container, we could build it in the toolchain repo.
We could build and push the container from the toolchain repo. Yeah.
But honestly, if we think that something like a relatively simple set of can we exec this in an older platform testing is good enough, then I think there's no reason to maintain our own build and test Docker environments. I think using GitHub's doesn't sound wrong.
The only thing that I think you might run into is if you wanted to test on something truly new, like Fedora betas or something like that. But that, I think it would make more sense to do as a one-off. You know, oh, there's new distros that we know may have breaking things. We have CI/CD for that separate from or added, but the majority of distros use whatever GitHub provides. Do we know what distros GitHub provides for compiling on?
GitHub can, so that question is a little bit orthogonal, is not quite the right question.
Yeah.
Generally, so what we implemented at Collide, and of course, everything Collide has done must be perfect, right? Is the build happens in the CI machines, and that saves the artifact somewhere, which we would do here.
Yeah.
And then it just runs a bunch of different containers with simple testing inside them. And some of those containers are distributed by GitHub. And I think as GitHub has dropped support for the very old things, we've started pulling containers in from other random sources. So you can run whatever container image you want. It's not.
So GitHub gives us, for Linux, Ubuntu runners only, but then those can run Docker and run any container that you want.
Right.
Okay, so what we're talking about is not using only GitHub's runners to do testing, but the functionality within GitHub workflows to call any container. So we could use just not maintaining our own containers. Is that correct?
And to be clear, not maintaining our own container to perform the build on. So the build goes to just using what GitHub provides for Ubuntu
Yeah.
22, or maybe we go to 2024 soon. I mean, we'll want to in a year, I think, when the long-term support is done. But using that plus the Osquery toolchain to do the build, rather than using a Docker container that includes the Osquery toolchain to do the build.
Yeah.
Yeah, I think as long as you and Stefano think this is reasonable, I don't think we lose much because we can implement testing through another path if we decide we want to run exec tests on, what do we do for launcher? We exec test all the way back to Ubuntu 2004. So I could look up where we find that container if people want, but we can write our own code or grab some of the launcher code, really.
I think that container is just still like there in the Docker library.
We have to they're in the Docker hub, certainly, but I think they're not in the GitHub.
Oh, maybe they're not. Okay. Okay, because I saw like Ubuntu 2004 in our Docker file, but I guess that our Docker file probably hasn't been built for a while, so they may not be in the library.
We definitely pull them from somewhere fishy these days, or not fishy, but somewhere different.
Okay, so given that discussion, I still have this PR in draft. What I'll do after this meeting is I will document what has changed in there, move it from draft, and then someone can maybe give it a review and we can merge it.
I take it back. We do use the GitHub the GitHub distributed ones. Apparently, though, the GitHub CentOS 7 ones are a little bit broken right now, so we stopped our CentOS 7 testing. But this was a pretty good pattern, so I think we could certainly implement this pattern pretty straightforwardly. Okay, so yeah, I think we're on board for all of the proposed changes. Stefano would probably be the only other thing, and then I don't know, try and review the code.
And then Stefano, like so you pointed me out that tool that we use to help like validate that the build is good with the given tool chain.
Yeah, it's it's a test. It's actually a test that runs. Forgot if it runs always or only on final release. I think it runs always. It's like a Python script, correctly. Test_release something.
It test release.py. Yeah, here it is.
Yeah.
Right. So you're checking out the libraries and stuff. And does this test run automatically in CI?
It should. Yeah.
Test release. It's in tools test, add Python test. Yeah, okay. Yeah, it looks like it probably does. So given that, if I cut a new release of the toolchain that's built on GitHub, and then I update the Osquery repo to use that new toolchain, and then the tests pass in that PR, we think that the toolchain is good.
So yeah, for the version you like, for what you have changed or actually not, I think definitely yes.
Yeah, I mean, in this one, I've attempted to change as little as possible, and then I do intend to go forward and start changing much more. And then I guess probably we need more thorough testing.
Yeah, there is quite trickier in the sense that, again, that test release PI only tests if any additional library appears, because again, something happened on during the linking process. So again, an additional library has been linked that it shouldn't have, but it doesn't highlight what gets statically linked in the binary. And it's kind of difficult to, like, the reason there isn't a test for it, because basically you need to trace and look at what the toolchain, like the CLang, is doing while linking your binary, and understand the command line there, and understand if it's doing something you don't want, basically.
You're talking about during the build process.
Yeah. Well,
okay.
Both. Yeah, both, in the sense that what you find in your binary, in the Osquery binary, final binary, is then likely dictated on how you build the toolchain. Because again, the toolchain, where it tries to find libraries, etc., should be forced to find libraries and have libraries only from inside its own folder.
Yeah.
And
okay,
even
so you're saying you run the strace to
yeah.
look for it, attempting to link to anything outside of like the repo root, or maybe repo root's not the right word, but the toolchain root.
And also, basically, we are building it against libc++, not libstdc++, and also we are not linking against the GCC. I forget the correct name, but the GCC runtime library, but it's actually using, again, the LLVM runtime library called compiler-rt. I mean, these are all flags. I seem to recall that it is mentioned in the description, long description in the README of the Osquery toolchain repo.
Sounds familiar.
But you can also see it, the flags inside the, like the script, the build.sh script that pulls CMake multiple times.
Mm-hmm.
And yeah, it's also the fact that technically the build process itself is a bit complicated, because first it builds GCC that is more, like, again, more detached from the system. Then the GCC builds the standard libraries, which are using the correct libc and are, again, detached from the system. And then and then it also builds a first version of CLang, which is then used to build the final CLang. And this is, again, all to incrementally, because you cannot do like one shot, incrementally detach everything from the system. Yeah, again, I don't have a specific step. Like, I can only say, again, yeah, the intent, what I said earlier.
So I guess to some extent we need to like try updating some things.
Yeah.
See whether, well, one, see whether it even completes building the toolchain. Then I guess we need to see, can then Osquery be compiled on the newer toolchain? And then we need to also further dig into, like, did the toolchain link all the appropriate things, or did it pull in anything else that was unexpected?
Yeah.
Okay. So that's it, but that's all like next steps.
Yeah.
And it sounds like some of that we could make some tests for, even if they could not identify where the failure was.
So I guess the tricky part is...
No, I'm wrong, because it's a static build. You can't just LDD it.
Yeah. No, I mean, so in most of the cases, I found that, like, if it doesn't work, it doesn't work when, like, you can build a toolchain, but then it is unable to build Osquery, or it is able to build Osquery, you go and launch Osquery and it crashes, or it gives some kind of error. Obviously, you can still be unlucky and it runs, but then it crashes, maybe using a very specific table that maybe we are not even testing, because we are not also testing everything on the CI, like especially events, etc. But yeah, I mean,
okay.
I guess let's look at it maybe positively, that at a certain point, we hope after a certain amount of tests that there isn't any additional weird thing.
Okay, but it sounds like what you're saying is the simple and obvious testing should catch most problems, but then before we go to really publish a new release with a new version of the tool chain, we need to do some like careful analysis.
Yeah. Again, what I was doing was like I was looking at it closely from the start, in the sense, again, how the toolchain was built, and then tracing and looking the command lines that it was using, understanding that. But
does the build, so does the build mention, like in the standard out, what library it links to, where the library is coming from? Like, is there a way to get that out of Clang in the build?
Well, yes and no. So when you build Osquery, you will have part of the libraries, but those are all the libraries specific to the project on the link line itself. But all the standard ones are hidden. You don't see it because we are always calling like the front end Clang, not the linker, which is LLD. So those ones can only be seen through strace, basically, because you need to see what the front end execute as LLD.
Okay, so it's not. It can't just be coerced into like some debugging output or something.
No, you can tell it to print the search path of the libraries. However, now I'm forgetting if, it's not always useful. I'm forgetting a bit why, but yeah.
Don't static scanning tools of binaries have a mechanism to get the library and the version that is used in the static binary out of it? Like static security scanning tools for before you publish something to the world?
Well, so that I think they do multiple things. So some libraries do have, but yeah, anyway, some libraries themselves have preprocessor defines that have the version that is then compiled in the binary, because it's also maybe presented, so it's not compiled away. And so since it's in the binary, and since the tool knows where it is in the binary, it can read that. But I'm not sure that every library has. And so short of that, it likely checks for which APIs and what's the interface of the functions. Short of that, I think it just uses some heuristic with patterns.
So it may not be accurate, I think is what you're pointing out. Okay.
It would be like limited accuracy, it sounds like.
Yeah. And we already saw this in the past with Osquery itself, with people coming with those type of scanning tools and thinking that the Osquery binary is linking against a certain version of library which is not there, or even that the version is incorrect, etc.
So this is does glibc have a way to list every library that it links against when compiling DLLs into a binary? Is that a correct statement of the question?
I'm not sure. So like glibc, the libc is just like it exists to give helpers for the C, or to implement the C functionality, plus the interfacing some of these are interfacing with the system because also there are syscalls there. But it doesn't, yeah, no, it doesn't have anything like any functionality to do that would need to come from the libraries. The only functionality itself it has that we are using is the semantic versioning of the symbol, or semantic, so symbol versioning that it's doing itself with its own APIs, but that's it. Yeah.
So what I'm understanding is in the end, like when we get down to this nitty gritty level, what we're really most interested in looking at is like, what paths is LDD specifically opening when linking?
Oh, yeah. Yeah. And you can check part of those into steps, like when you build the tool chain, how LLD is called. A part of that, the standard libraries it uses, or you shouldn't call it standard libraries, like the runtime library, etc., and the flag it uses, that part is fixed, or should be basically fixed. So technically, you can already see that when you build the tool chain, or when you try to build Osquery. But the rest, like the libraries we ask to link from the Osquery project, those you can see while you build Osquery itself.
Yeah, so I guess that's a separate.
Yeah,
that's a separate concern. What we're talking about specifically is like the libc++ and libpam, I guess you said. Are there others?
No, libpam is indirect through libc, etc.
Okay.
The connection is, yeah. No, it's the like the runtime library, the compiler RT. I forget what's the actual name of the library, which actually, sorry, that one though, it's compiled statically already inside. So actually it wouldn't be when you wouldn't look for it when you build Osquery on LLD. You may, because it has to be statically compiled inside the libc++ library. So when you build a tool chain, the compiler RT runtime is already integrated in the libc++ library. So to make sure that it is present, you will need to look for its presence when it builds the libc++ libraries during the toolchain compilation.
So primarily or only, it's only like the libc++ and its dependencies that we're looking for during that process? Are there other libraries that we need to be paying attention to?
Yeah, no, that's, yeah.
Okay.
Because the other ones, the other ones, if it's incorrect, if they are linked as shared, that test release script will find them. And anyway, you have to check because maybe you are trying to link them statically so they don't appear. And so if you, again, analyze when it's building libc++, it should be, yeah, you should be able to determine if the correct runtime libraries has been compiled in.
Okay. Yeah. Okay. Well, thank you so much for all of your insights.
Yeah,
no, I think for the most part, I'm thinking that like we already resolved these other things earlier with the sort of like, let's try to do the same build as we've been doing, but through, more CI supported. And then we're going to move on to the, let's try to update the tool chain. And when we do that, when things are looking successful to some extent, like, I'd love to call on you, Stefano, to help us just like make sure that we're verifying the right things when it comes to this problem. But I think that before that, I know that you're busy. Before that, as I do some of this work, I can just see, does it actually build? Does it actually run when it's built? etc.
Yeah, I should say that currently I feel that the biggest concern, hopefully, is just handling any additional or removed CMake configuration option in LLVM while building the toolchain. And the general shape of how we do the compilation is correct, because technically between LLVM 9 and LLVM 14, the partial work I've done, I had to restructure a bit how the process of those intermediate step of constructing the toolchain.
Okay.
I hope that nothing else changed, because unfortunately, again, they changed themselves the build system, how they structured the build. So yeah.
Okay.
Hey,
So challenges may be encountered. Go ahead, Philip.
Sorry. Hey, Stefano, are you aware of a thing called a linker map?
Yes, sort of. I at the business
Sort of, kind of.
used that.
One of our kernel devs says that what y'all are trying to do might the linker map might provide it, but it's massive and hard to read. So I'll get some more info and see if I can get something more helpful on that.
True. Yeah, because it dumps the. Yeah, I haven't thought about it, because normally I thought, it dumps the libraries. I thought that when you would use it to modify or ensure some things, like it's forcing some kind of linking without using it. But anyway, yeah, it's definitely it could help in knowing what has been linked. Yeah. Makes sense.
Okay, so it's like something you add to your LD flags and it outputs that when doing the linking, I guess.
I probably need to drop now, but Zach, I will try and look at your PRs. And good luck with linking.
Thank you.
Thank you.
Yeah, I wonder if we get the file paths in these linker maps. You get like addresses and names and that kind of thing. I'm not sure that you get the file paths. Archive file location, compilation unit, referencing the archive. Okay. Oh yeah, we could cool to look into that more. And oh yeah, in this example, I'm looking at some blog post from memfault.com. In any case, that's makes it look like there's some file paths.
Yeah, it should show the object files even. Yeah.
Okay, cool. I added a note to the meeting minutes suggesting that. Thanks for the suggestion, Philip. Anything
Yeah,
else that? Oh, go ahead.
If you have any questions, feel free to hit me up in our dedicated chats.
Okay.
I can connect you with the developer that I know.
Okay, cool. Thank you.
Yeah.
I don't see anything else on the agenda. Did other folks have things that they wanted to cover today? We have got 7 minutes left in our scheduled time.
Nothing big. I do have I've put together a Python script. So going back to our discussion before Christmas or before the new year, and EFI detection, I have a Python script now that will parse this stuff, and I've put it into classes and stuff so that you can parse EFI boot manager, boot entries, all those kinds of things. I'm putting some final stuff on it, and then I'm going to go through our process to share that and see if I can share that to y'all. And then if there's a way to refactor that into an Osquery table in some way, would be awesome. But I think it goes. I think it will show a lot of the uniqueness that you have to go through to figure out values from the various different places.
Yeah. Well, yeah, and on that front,
Byte code.
I think you can work with our the team at Fleet to potentially get that onto my plate.
Okay.
So please,
I'll do
go
that
ahead and do that.
Yeah.
Yeah.
Okay. So
Thanks.
yeah, cool. Alrighty.
Anyone else? Thank you all. Good to see you. Olympics are really soon, right, Stefano?
Yeah.
I keep forgetting. 2026, when February 6th, actually, they should have been already started, but
Oh, they already started.
yeah, 6/20, actually. Oh, no, sorry, February. So 6th February